Morning. How is everybody today? Y'all glad to be at home or sad not to be at school? It's kind of a loaded question, isn't it? We miss our friends when we don't go to school, but it's awful nice to stay at home, isn't it?
Yeah, my sister might be sick. I don't know. So.
Oh no.
A bad thing, and my grandfather died a few days ago.
I know. I'm so sorry about that.
Yeah, but Miss Gwen bought us pizza, so hey.
Well, that was sweet.
And one of my brother's friends, Caden, brought.
That's nice. That's very nice. We'll give it a few more minutes. We're missing a few other people. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're missing 4. So we'll give it a couple minutes. He might not have heard you.
Or they might just put a device on and not show up. How do we know?
Hopefully nobody would do that. Hopefully I won't have to start making everybody turn their cameras on. So what we'll do is we're going to start out by looking at our homework. Hopefully you all got the email last night with the answers to check it. So we'll go through and take a look at what we did on Thursday, and then answer any questions that we might have. We will review what we did on Thursday, because one of the things about, especially about graphing and about learning these equations that pertain to graphs, repetition is key. Okay, the more we repeat it, the more we practice it, the better we're going to get it and understand it. So that's my goal, is for you to understand the relationship between these different equations, how we can change from one equation to another, because we actually have a few other equations that we're going to be learning as we go through this unit. So it's going to be the kind of thing where we're going to continue to add to it. So that's why I want to make sure that each time we meet, either online or in class, that everybody has a grasp of what we're doing, because when we do the next section, it's going to build on what we did previously. So I want to make sure that everybody's good before we move on. I don't want you to be lost. So as always, let me know if you need help. Don't just stay lost. Here comes Zoe Watley. Who else do we need? Good morning, Zoe.
Morning.
See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We're missing Chad, and we're missing Sadie, and I have to visually picture the seating, how y'all usually sit in class, to see who all we're missing. And Kate, no, Katie's here. Who am I missing? Oh, well, we'll give them a chance to log in just a minute. Okay, so let's go ahead and take a look at the homework from Thursday. Do what?
I think I remembered who it is. It's Evelyn.
No, Evelyn's here.
Grant.
Grant, goodness gracious. Okay, hopefully they'll be here in a minute. All right, I'm gonna go ahead and share my screen, and we will pull up our homework from Thursday. We'll watch for them to log in. I fix it where I can see. Okay, so hopefully I'll see if they pop up in a minute. All righty, so go into So on Thursday, okay, real quick, actually what I'm going to do is I'm going to back up for just a minute. Real quick, go ahead and flip all the way back to the beginning. What is that, lesson 30? No, lesson 29. Oh, here comes Sadie. All right, we're going to scoot back for just a minute and start at lesson 29 and just kind of do a quick review as we go through. And then we'll answer questions as we go along. So please don't hesitate to let me know if you have a question. Okay, so in lesson 29, we learned about the coordinate plane. We learned that we have an X and Y axis that divides our plane into 4 quadrants. And with our 4 quadrants, we start in the top right-hand corner and then go counterclockwise and move around to the 4 different quadrants. We also learned that with those 4 quadrants, the location of the quadrant shows us whether our X value is positive or negative, and the Y value is positive or negative. So we talked about how when I look in quadrant 1, both X and Y are going to be positive because they are they are above the X axis and to the right of the Y axis. Quadrant 2, I'm going to have a negative X and a positive Y because it is to the left of the Y axis, but above the X axis. And then quadrant 3, both are going to be negative because they are below the X axis and to the left of Y. And then 4, you're going to have a positive X, negative Y because you are below the X axis. I'm sorry, you're to the right of the Y axis and below the X axis. Okay, so we've got our 4 quadrants. We can see how we can determine positives and negatives based on the location in relation to the X and Y axes. Okay, so then we moved along to lesson 30, and this is where we learned that I can set up a table. And we talked about how our X values are called our independent variables, and we change those. We can choose, typically when we're going to set up a chart to graph an equation, we're going to choose 5 values for X, 0, 1, 2, -1, -2. That way I've got my 0, 0 point, or I've got my 0, and then I've got 2 that are positive and 2 that are negative. So that's how I choose what to plug in. If my directions do not tell me what to use for X, I get to pick, and those are the 5 that I want to pick, okay? Our next column after the X values is where we have Y equals whatever the equation is. And that's where we plug in our X's to solve for Y. And then I went ahead and put a third column. The text did not, but I did, just so I can see my X and Y values together. So I'm not having to jump over here to get X and over here to get Y. I've got them together in one column. So that's just something that I like to do. And then once we know our values, I can plug my X and Y values, plot those points, connect the lines or connect the dots with a straight line, arrows on the end to indicate an infinite number of solutions. So that was lesson 30. We moved on to lesson 31, and we talked about the slope of a line. And I've got 2 ways that I can find the slope of a line. The first one is if I have 2 points already graphed, I can count it and I can decide, am I going up or down, then left or right? Remember, slope is rise over run. So I have to look at the vertical change over the horizontal change. And so that's what we were talking about right over here in this lesson, in lesson 31, where it says rise over run. That is going to be your vertical change over the horizontal change, up, down, side, side. Okay. We also learned that if I can't count it, if I don't have the, if I can't just count, I can use ordered pairs. And again, I have to remember that my vertical change involves my Y coordinates or my Y values. And so I have to have my Y values in the numerator, and I find the difference of those. And then my X values are in the denominator. and that is the difference of those in the denominator. So that's my horizontal, okay? So I have y2 minus y1 over x2 minus x1. So if I'm given two ordered pairs, I just plug them in to solve for my slope, okay? Then moving on to lesson 32. This is where we talked about the slope-intercept form of an equation. This is y equals mx plus b, where m is the variable that we use to describe our slope. B is the variable that we use to describe the y value of the y-intercept. And we talked about how the y-intercept is where my line crosses over the y-axis. So since it crosses over the y-axis, that means my x value is always 0. Okay, so y-intercept is going to be an ordered pair, x is 0, and the y value is whatever b is in my equation. Then we had some graphing going along with that. Lesson 33, we moved on to a new equation. We already had y equals mx plus b, but now we've moved on to a new equation called the point slope form. So I want you to think about this for a minute. In 32, we did slope intercept form, and that tells me the slope and the y-intercept. That's why it's named slope intercept. Okay, that's what information I can get from that. Now, when we talk about point slope form, that means I have a point on my graph or an ordered pair, and I have the slope. So my equation, y minus y1 equals m times x minus x1. So we talked about how x1, y1 is our point, and m is the slope. Okay, so if I'm given a point and a slope, I can use point slope form, plug in my values, and then we learned that once I've done that, I can change it to slope intercept form. Okay, so if I'm given a slope and I'm given a point, I can plug that in, and then I can solve for y equals mx plus b. So I can go from y minus y1 equals m times x minus x1. We learned how I can go from there to y equals mx plus b. And that's what we worked on Thursday as well. Okay, so looking over our very quick little review that we just did, questions on homework from any of these sections that we have just reviewed? Any questions, any of these you would like me to go over? Any of the changing from point slope to slope intercept, Chad?
Were we supposed to graph those in the book or on notebook paper?
Okay, so for lesson 33, okay, activities 2 and 3, we're going to be on notebook paper to hand in. The ones that we said were in the book, I think we notify, and so like, let me look if you look at lesson 31, on page 69, we did some in the book, but in class, I noted that the ones on the right-hand side that we had for homework were on notebook paper. Okay, so page 69, you should have yourself a note that on the right-hand side, those are on notebook paper. And then if you look on page 70, those graphs 1 through 6, and I put graph on paper. Okay, so those should be on paper. Then on lesson 71, activities 2 should be on paper. We didn't, 3 was in the book, right? On page 72, we did activities 3 in the textbook. Is that correct?
Yes. Yes.
Okay. So then lesson 33, activities 2 we did in class. So activities 3 is on graph paper. So I'll make a note there, on graph paper, because those will be handed in. I think that was just a repeat of that one. Okay, so any of those that you want me to go over Is everybody okay with changing from point slope to slope intercept? Any questions on any of that? All righty, then we will keep on moving. So today we're going to start with lesson 34, graphing linear equations, horizontal and vertical lines. So what I want to do for a minute is think about what we already know about horizontal and vertical lines. And the first thing I want to talk about is obviously we know that horizontal is going to be our side to side. And what did we say the slope of a horizontal line is? Slope of a horizontal line is going to be 0. Good. And then a slope of a vertical line, or a line that goes up and down. And so a vertical line has no slope. Okay. So you can either put it as no slope or undefined. Either way is both correct. But if it's easier to remember 0 and no slope, that is perfect. Okay. So it says a horizontal line is a line that is parallel to the x-axis. So let's think about that for a minute. If it's a line that is parallel to the x-axis, then I think about, okay, well, the x-axis runs side to side. So I know that my horizontal line is going to either be above the x-axis running side to side, or it'll be below the x-axis running side to side. And it says because the line parallels the x-axis, the distance from the x-axis is constant. The formula for the equation of a horizontal line is y equals c, where c is the constant distance from the x-axis and the slope of a horizontal line is always 0. So let's think about this for a minute. If we just said, think about when we have our equation y equals mx plus b. Okay. So what would happen if my slope was 0? So then I would have y equals 0 times x plus b. And actually what I'll do is I'll do that and that. Okay, so if I have 0 times x, what is 0 times x? That would just be 0, right? Plus b. And 0 plus b is going to look like that. Okay, so we just said that the slope of a horizontal line is always 0. So if I plug 0 in for m, and I make my calculation and I multiply 0 times x, then that goes away. So all I'm left with is y equals b, the value of the y-intercept. And it's going to be a horizontal line just going through that y-intercept. So what I want you to do is go ahead and get a piece of graph paper for a minute. All right, and on that graph paper, what I'm going to do is I'm going to write horizontal lines, y equals b. I'm going to call it y equals b. The textbook says y equals c because they're saying that it's a constant or it's the same number. I'm going to go ahead and call it y equals b just because b or c, you can use either one, okay? I'm just saying b because when I plug in that 0 for slope, that's what we ended up solving for. All right, so I'm going to give you an example of an equation. If I have y equals 0x plus 4, okay, if my slope is 0 and I've put 0 in for m, then I end up with y equals 0 plus 4, therefore y equals 4. So if y equals 4, that means in my ordered pair, x is 0, y is 4. So that's my y-intercept. So now what I'm going to do is I'm going to draw me a little graph. X, Y. And I'm going to graph 0, 4. So I start at my origin and I go up 1, 2, 3, 4. 1, 2, 3. So remember, if we're saying this is a horizontal line, I don't even have to worry about graphing any other points because I already know that this is going to be a line that is running parallel to the x-axis. And this tells me that y equals 4. So if I see an equation that just says y equals a number, I know that it's going to be a horizontal line. And that line is going to cross over the y-axis at that number for the y-intercept. Is everybody good with that? Okay. So if I have the equation y equals 4, and that's all I know, then I need to understand immediately, like if I saw the equation y equals 4 and it says, what is the slope? Then I need to know that the slope is going to be 0. Because that's why the x value went away. If m is 0, then x is gone. Okay? So now I'm going to hang on to that piece of paper. We're going to go back to it in just a minute. But what I want to do is I want to go back. Okay, so now we're going to look at a vertical line. And it says a vertical line is a line that is parallel to the y-axis. So remember, if my y-axis is up and down, then this is going to be a line that's parallel to that. So it's either going to be to the left or the right of the y-axis. And it says the distance to the y-axis is constant. That means it does not change at any point. So there's, and it says the formula for the equation of a vertical line is x equals c, where c is the constant distance from the y-axis, and a vertical line has no slope. Okay, so the main thing to remember here is that x equals c, just like up here, we said y equals c. So now we're going to go back to our graph paper real quick. And I'm going to make a note that a vertical line has no slope and is parallel to the y-axis. X equals c, where we said x is that constant number, okay? And I'm going to put here, c is the value where the line crosses the x-axis. Okay, so vertical lines, I have x equals something. So let's say I have x equals 4. Okay, if x equals 4, then the y value will always be 0. So now my ordered pair is going to be 4, 0. So when I'm dealing with a vertical line, I have my value of x and y is 0. Whereas our horizontal line, x is 0 and y is the number. So now if I'm going to do my vertical line and I'm going to graph x equals 4, that means my ordered pair will be 4, 0. That means I move to the right 4 and I do not go up or down. And it's a vertical line now. So now it's going to look like that. So again, this is x equals 4. Okay, so if you see an equation that says x equals something and there's no y, there's no b, there's no y, there's no m, all it is x equals 4, I know I'm dealing with a vertical line and my line runs through that point on the x-axis. So I looked for my point of 4 on the x-axis, and then I just drew a horizontal line. I don't have to worry about knowing any other points on the line. I know it's horizontal. I know it runs through that point. Okay? So horizontal lines, y equals b. Vertical, x equals c is just kind of a way, but the main thing is to remember y equals something is going to be a horizontal line, x equals something will be a vertical line. And those are just things that you just have to learn, okay? There's no fast and easy way. Just memorize that if it's y equals something, you've got a horizontal line because the slope is 0, therefore the rest of the equation went away. If it's x equals something, it's going to be a vertical line running through that point on the x-axis. All right, let's go back to the book. So now it says, write an equation of the line that passes through point 24 and is parallel to the x-axis. So think about, what I've got to think about is a line that's parallel to the x-axis is going to be what kind of line? I look back up here, a line that is parallel to the x-axis is horizontal. So I know I've got a horizontal line, which means I'm looking at the value of y. So I need to look at that point there. If it's 2, 4, then I know y equals 4 because it told me a horizontal line since they said parallel to the x-axis. Okay, so let's practice with that a little bit. Let's look at the classwork. It says, write an equation for each line described below. So first of all, it says a line that passes through the point 5, 2. So we've got that. And then it says parallel to the x-axis. The first thing I want to determine is this going to be horizontal or vertical? So I'm going to look over here. A line that is parallel to the x-axis is going to be a horizontal line. So I'm going to make myself a note. Horizontal. And if it's horizontal, it's going to be y equals something. Therefore, I'm going to look over here and look at what is my value of y in the order pair they gave me. Chad?
But it's parallel to the y-axis. Doesn't that mean it's vertical?
Oh, I'm sorry. I totally just jumped over. Yes, thank you. I read the wrong thing. Thank you, thank you. So let me fix that real quick. I was just going right along with what I was doing a minute ago. Thank you. So this is a vertical line. Therefore, I know I'm going to have x equals something. And the place that I find that something is what is the value of x in the ordered pair they gave me. So x equals 5. So if I was graphing that, I'll just do kind of a rough graph right over here. And I had 1, 2, 3, 4, 5, 6. Okay, so rough graph. And then I would graph my point at 5. And we just said because it's x equals something, it's going to be a vertical line. So it's going to look like that. The things to remember, parallel to the y-axis is a vertical line. I have to look for the value of x. Parallel to the x-axis will be horizontal. I'm looking for the value of y. Okay, so they're kind of flip-flopped in that sense. So let's look at the next one. A line that passes through point 2, -3 and is parallel to the x-axis. So now that's going to be horizontal. So I'm paying attention to y equals something. I look at my value of y here. So that's -3. So again, just a quick little graph. You don't, I mean, this is just for you to be able to see. I would automatically know that I would have, I'm at y equals -3. So I'd go down 1, 2, 3. And I know I'm dealing with a line that is parallel to the x-axis. So that would be y equals -3. All right, let's look at this one that says a line that lies on the x-axis. So if I'm looking at a line that lies on the x-axis, if I'm looking at a line that is on the x-axis, then it's going to look like that. It's just going to lie right on top of the x-axis. Okay? So in that sense, think about if I have it that lies on the x-axis, that means that y equals 0. Okay? So the value of y is 0 there. So then I know that the ordered pair I would graph would be 0, 0. So that would be at my origin. And then my line would just go through there. Same thing if it lies on the y-axis. I would have my graph. And so I'll just go ahead and make a note, since this isn't in the book, lies on y-axis. Again, that would mean that x equals 0. So my ordered pair I would graph would be 0, 0. So it would be right there, but then the line would just be right there on top. Okay? So if it says that the line lies on the x-axis, you know y is 0, and it's just going to run right along that x-axis. If it lies on the y-axis, I'm going to have a vertical line that goes to the point 0, 0 and just goes straight up and down the y-axis. Questions on that? All right, let's look at activities 2. And it says, write an equation for each line described below. Okay, so we're going to have to pay attention. Does it lie on the x-axis or the y-axis? And then look at the ordered pair. So let's look at the first one. A line that passes through point 47 and is parallel to the y-axis. So remember, we talked about if it says parallel to the y-axis, then we are looking for x equals something. Okay, so I know x equals, and this is where I look at my value of x, so x equals 4. Let's look at the next one, a line that passes through the point 25 and is parallel to the x-axis. If it's parallel to the x-axis, I have y equals something, and I look at the value of y in my ordered pair, so y equals -5. All right, I want you to do the next 4. I'll give you just a minute to do the next 4. And then we're going to look at them. Pay close attention. Is it on the y-axis or the x-axis? And would it be x equals something or y equals something? All righty, so let's take a look at these. Parallel to the x-axis tells me I'm going to have y equals something. I look at the value of y equals 1. Parallel to the y-axis, I know I'm going to have x equals something. I look at my value of x, -1. Parallel to the x-axis, y equals something. Y is equal to 3. And a line that lies on the y-axis, we just talked about a minute ago. We looked at our example. The book gave us was if it lies on the x-axis, you're going to have y equals 0. But if it's on the y-axis, you're going to have x equals 0. Any questions on that? Okay, now what we're going to do is we are going to look at how to graph each of these. Okay, so let's look at activities 3. And let's see, let's number the activities we just did. So in activities 2, we'll just go down the line. 1, 2, 3, 4, 5, 6. So we'll just number these to correspond. 1, 2, 3, 4, 5, 6. I know in the activities, it goes top to bottom that we just did, and we're going to be graphing them going side to side. Okay. So if we look at the first one, the first thing I want you to do is go ahead and by number 1, write x equals 4. So think about if x equals 4 and I'm writing an ordered pair, I plug that 4 in for the value of x, and what is y going to be? 0. If x is 4, y is 0. So that tells me my ordered pair I'm going to graph. So I'm going to graph 4, 0. Go ahead and do that. So remember, left, right, up, down. I'm going to the right 4, 1, 2, 3, 4, and I do not move anywhere. Okay, so we know that if x equals 4, I've graphed my ordered pair 4, 0, and that's going to be a vertical line. It's going to look like that. For number 2, I'm going to write y equals -5. If y equals -5, my ordered pair, x is going to be 0, y is -5. Please make sure that you're writing this above your graph. That way, you've got it written down immediately what to graph. It makes it a whole lot easier to see it, okay? So if y equals -5, I'm going to plug in -5 for the y value of the ordered pair, and I know that x is going to be 0. So now I'm going to graph 0, -5. So that means I start at 0 and go down 1, 2, 3, 4, 5. And it's going to be a horizontal line. So it's going to look like that. Notice that when I had to draw my little lines on my graphs, notice that some of them I had to kind of cheat my x-axis up or down a little bit to make it, make enough room. So it's always fun when you're drawing a graph. It does not have to be proportional. Like you don't have to have the exact same amount of room when you're doing your x and y axis. If you need to slide an axis up or down or side to side to give you room to graph a bigger number, then that's fine. So just like if you look at number 2 and number 5 of my graphs, I moved the x-axis up so I could graph -5. And then on number 5, I had to move it down. So let's go ahead and graph number 3 together, and then I'm going to have you graph the rest of them. So number 3 says a line that passes through point 31 parallel to the x-axis. We said that was y equals 0. So if y is 0, if y is 1, x is 0. So I've got 0.01. So that means I do not move right or left. I go up 1, and I've got a horizontal line. So now I want you to go ahead and graph numbers 4, 5, and 6. Be sure to write x equals whatever, y equals whatever, write your ordered pair, and graph it. Once you've done those, check. You can look at the screen and check them. Okay, so in number 4, you had x equals -1. So that means when you write your ordered pair, you plug in -1 for the x value, 0 for the y value. If I have x equals something, it indicates a vertical line. Therefore, my point -1, 0 is the point that my vertical line will run through. Number 5, y equals 3. I plug in 3 for y in my ordered pair. That means x is 0. If I have y equals anything, I know it's going to be a horizontal line that runs through point 0, 3. And then finally, number 6, x was equal to 0. So our ordered pair is 0, 0. And then I've got a vertical line going along the y-axis. Any questions on those? Awesome. All right, let's move on to lesson 35. And so it says, recall from lesson 32 that the y-intercept of a graph is the point at which the graph crosses the y-axis. This is the point at which x equals 0. Likewise, the x-intercept of a graph is the point at which the graph crosses the the x-axis. This is the point at which y equals 0. To find the coordinate of the y-intercept of a graph, you can let x equal 0 and solve for y. If you're trying to find the coordinate of an x-intercept, let y equal 0 and solve for x. So if I'm looking at this equation, 2x plus 3y equals 0, and I want to find the x and y intercepts of the equation, I'm going to look up here just at what they said. Step 1, I'll let x equal 0 and solve for y. And 2, let y equal 0 and solve for x. So notice that's what they did here, is they let y equal 0 and solve for x. So they had 2x plus 3y equals 6. So notice they plugged in 0 for y and solved for x, because 2x plus 3 times 0, 3 times 0 is 0. So I just end up with 2x. I'll write that here, 2x plus 0 equals 6. And that's how they ended up getting 2x equals 6. Divide by 2, divide by 2. So x equals 3. So in that equation, to find the x-intercept, let y equal 0 and solve for x. Now the opposite of that, I want to use 0 for x and solve for y. So again, I had 2x plus 3y equals 6. So I'm plugging in 0 for x. So 2 times 0 is 0. So 0 plus 3y is 3y equals 6. Divide by 3, divide by 3. So y equals 2. So the y-intercept would be at the point 0, 2. Okay, so the x-intercept we found was 3, 0. The y is 0, 2. So let's practice with that for a minute. It says find the x and y intercepts of each equation. Okay, so this is the equation I'm starting with, 2x plus y equals 4. So the first thing I'm going to do is, and it doesn't matter which one you do first. You can solve for x first, solve for y first. It does not matter. But if I'm going to solve for x first, that means I'm going to go ahead and just rewrite my equation so y'all can see it in two different places. So I have 2x plus 0 equals 4. That means 2x is equal to 4. Divide by 2, divide by 2. So x equals 2. Then I'm going to rewrite my equation. 2x plus y equals 4. This time I'm plugging in 0 for x. So I have 2 times 0 plus y equals 4. 2 times 0 is 0 plus y equals 4. So y equals 4. So in this, it says to find the x and y intercepts. So if x equals 2, I know that my x-intercept is going to be at point 2, 0. I know my y-intercept will be at point 0, 4. Questions about that? Anybody not sure how I got what I got? The first step was to let y equal 0 and solve for x. If x equals 2, then that means the x-intercept will be at the point 2, 0. That is where my line is going to cross that x-axis. If I'm solving for y, I let x equal 0, solve for y, so that means my intercept, my y-intercept, where it crosses over the y-axis, will be at 0.04. Let's look at the next one. I have x plus 3y equals 9. I'm going to solve for my x value first. So that means I have x plus 3 times 0 equals 9. X plus 0 equals 9. Therefore, x equals 9. So my x-intercept is 9, 0. Remember, anytime I'm describing an intercept, I want to make sure to write it as an ordered pair, okay? I want to write it as an ordered pair if it's talking about an intercept. Then again, x plus 3y equals 9. I'm going to let x be 0 plus 3y equals 9. Therefore, 3y equals 9. So I'm going to divide by 3, and y equals 3. Therefore, my y-intercept is going to be 0, 3. Now, using that, we'll look in just a minute at how that's going to be useful for graphing a line. We'll practice with this a little bit more. We're going to do one more together, and then I'm going to have you do the next two on your own. So if I have x plus 4y equals 12, I'm going to plug in 0 for y. So I have x plus 4 times 0 equals 12. X plus 0 equals 12. So x equals 12. So my x-intercept is going to be 12, 0. X plus 4y equals 12. X plus 4 times 0 equals 12. So x plus 0 equals 12. That means x equals 12. I just solved for that. Good grief. I'm not fully awake today. We're solving for y this time. X plus 4y equals 12. Sorry. I almost did it again. We're plugging in 0 for x plus 4y equals 12. So 4y equals 12. Divide by 4, y equals 3. So that means my y-intercept will be 0, 3. Okay? So now I want you to go ahead and work the next two. Solve for both x and y intercepts. If you have questions, let me know as you're working on these if you're not sure what to do. But look at the example, okay? I'll leave it to where you can see both of them or see all of it. If you're solving for x, let y equal 0. If you're solving for y, let x equal 0. And as soon as we finish these, we'll go ahead and take our break. We're a little bit over, but we'll take our break. All right, we'll go ahead and take a 5-minute break. When we come back, we will check these. And then we're going to look at how we can graph them. Okay, so take a break. All righty, we'll get ready to get started back. If you haven't checked your answers for those 2 and activities 2, go ahead and start out by doing that. Look on the screen. Excuse me. The first one we found together that the x-intercept was 12, 0 and y was 0, 3. In the middle one, you should have found that the x-intercept was 3, 0 and the y-intercept was 0, 5. And then the last one, the x-intercept is 4, 0 and the y-intercept is 0, 3. Any questions on those? All righty, so the next thing we're going to do is we're going to look at how we can graph a line using that information. Okay, so notice turn your page and it says on activities 3 on 78, it says use the intercepts to graph each equation from activity 2. So you can see, like I said, sometimes you have to kind of move your lines over and stuff. So if we look at the first one, what I'm going to do first is I'm going to go ahead and write my x-intercept was 12, 0, and my y-intercept was 0, 3. So I'm going to put those ordered pairs. So notice what I had to do for us to be able to fit this graph on this paper. I'm going to have to actually count by 2s. So you can see where I have it labeled as 2, 4, 6, 8, 10, and 12. Okay. And I just had to move my y-axis over to the left some to be able to make room. So that means like this side would be -2. Now, again, I'd be going by 2s. So I would have, this will be -2, -4, -6, 2, 4, 6, 8. All right, so look at this one. If I'm graphing 12, 0, then that means I move to the right 12 and I do not go up or down. So that's my point right there. Now the next one, notice it's 0, 3, and 3 is an odd number, and I have graphed my graph according to even numbers. What I'm going to do is on this one, I'm going to have to graph it halfway between the numbers 2 and 4. Okay, so if that ever happens and you've had to make an even number graph, or if you've been given an even number graph and you need to graph an odd number, then you just go halfway in between, because halfway between 2 and 4 is going to be 3. So I would just graph that point right there. Okay, so this is where I would have 0, 3. This is where I have graphed 12, 0. Everybody good with that so far? Remember I said that the minimum number of points I need to graph a line is 2 points. I like to have 3 to 5 just so I can see the trend and I can make sure I haven't made a mistake, but I can graph a point given 2 lines, and that's what we're going to do here. So what I'm going to do is change my color. And so I've got my point 0, 3 and my point 12, 0. So I'm going to connect those 2 dots, extend it out on either end, and there is my line. So all I did was graph the y-intercept, which is my ordered pair that crosses over the y-axis. My x-intercept is where my line crosses my x-axis. I graph those 2 points and draw a line. So let's look at the next one. So we found that our ordered pair in this one, we had 3, 0 and 0, 5. Go ahead and graph those 2 points. And you can see on this one, I kind of shifted it a little bit too. So 3, 0 and 0, 5. Three, 0 tells me I'm going to start at my origin and move to the right 3 places, but I'm not going to move up or down any. So that is going to be 3, 0. 0, 5 tells me I start at my origin. I do not go left or right. I just go up 5. 1, 2, 3, 4, 5. So it's going to be right there. So I've got 0, 5. I have 2 points. I can connect them with a line. I extend it out a little bit. And there you go. go ahead and do the last one on your own. We found that our X and Y axes were 4, 0, and 0, 3. So you should be graphing this one. So if you plot your points, 4, 0 means I start at my origin, move to the right 4, 1, 2, 3, 4. For my y-intercept, start at my origin, go up 3. Connect my points with a line. Extend it out. And there you go. So basically what these are just telling us are the X and Y coordinates for where my line crosses the X-axis and the Y-axis, okay? We're gonna move on to lesson 36. And one of the things I'm gonna be doing is, and just probably as soon as class finishes, I'm gonna start putting together, I've got your graphing packet that we're gonna be working on, okay? So we will be working through a packet that has all of this information that we're going to be kind of putting together. I may not get it to you until probably maybe sometime this early evening. So be looking for an email from me this afternoon, early evening, that will have a packet for you, okay? I'm going to be putting some places for you to do some definitions, because it's going to be super important that we practice with these equations, that we understand the equations, that we know what each of these points mean. So it's going to have some definitions with it that's going to go with this unit. And then it's going to have some practice with these things that we've been working with. And so it'll be covering everything that we have covered up to this point. And I'll tell you exactly what is due when and all that good stuff, okay? So in the email that I send, it'll tell you everything that's due from the packet. All righty, so let's look at lesson 36. Now we're talking about perpendicular lines. Okay, so lesson 36, perpendicular. Let's think about what perpendicular means. Okay, Chad?
So is the packet the only homework we're gonna have this week?
It just depends. It depends on what we get covered in class. If we cover everything from the textbook in class, then yes, it would be. All right, so, Somebody else have a question? Okay. So perpendicular lines. It says, consider the graph of the line y equals 2x below. Okay. So it says y equals 2x. So think about this for a minute. One of the things I want you to get comfortable with is sometimes your equation may not have all of the things. So if we think about y, let me change that color. If I think of y equals mx plus b, okay, and in this equation, they've told us y equals 2x. What is missing in this equation? If I have y equals mx plus b and I have y equals 2x, notice that what I'm missing is this plus b part right here, right? So what would the number be that I could put in there that it could either be there or not, and it doesn't change the value? Good, Kinsley. That means that b is 0. Okay, so if it is not there, I have to understand that b is 0. Because if it's not there, and it doesn't matter if it's there or not, then it's just telling me that b is 0. All right, so if I just have y equals 2x, that means b is 0. So that means my y-intercept is just going to be 0, 0. So you can see that you can see that they have a point in the origin. Okay, remember 2 tells me my slope, m equals 2. So when I'm talking about slope, that would be 2 over 1, which would be the same as negative 2 over negative 1. Thinking back to slope. So remember, if I've got a slope of 2 over 1 and I start at that point right there at 0, 0, that means I go up 2, right 1, up 2, right 1, or I could go down 2, left 1. So remember that when you're graphing and you're using your slope, you can always write it the way that it's originally given to you. And then you can also look at the opposite of it depending on if you've got positives and negatives and things like that. Okay, so they've given us the equation y equals 2x. So the slope of the line is 2. When the slope of a line is positive, the line goes up as it moves from left to right. So that's, remember we talked about that yesterday, or not yesterday, Thursday. Remember we have our slopey man. It's that whole, my line that goes from left to right up is positive. If it goes from top to bottom, moving from left to right down, it's negative. Vertical lines are undefined, horizontal lines equal 0. And then it says, consider the graph of the line y equals negative half x. Okay, so again, that would be y equals negative 1/2 x plus 0. So again, that tells me my y-intercept is 0, 0. So that's what they've done here. And then when I have a slope, when m equals negative 1/2, that would be going one direction. The other direction, I could go positive 1, negative 2. So that means I would go down and then right 2, or up 1, left 2. Okay, so if I'm starting at that point and I went up 1, left 2, or down 1, right 2, down 1, right 2, okay? So we looked at the slope of 2, and we've looked at the slope of negative 1/2 x. So it says the slope of the line is negative 1/2. When the slope of a line is negative, the line goes down as it moves from left to right. But now it says, notice what happens when we graph both of them on the same plane. Okay, when we look at both of these equations on the same plane, notice that where they intersect right here, this is a perpendicular intersection, okay? So perpendicular means that they intersect to form a 90-degree angle. And remember, when I see that little red box right there, that's what they're telling me, is that this makes a 90-degree angle. So perpendicular lines intersect to make a 90-degree angle. And also we call a 90-degree angle a right angle. Those mean the same thing. So it says lines whose slopes are negative reciprocals. I want you to circle that word, negative reciprocals. If I have negative reciprocals, I've got perpendicular lines. Okay, so here are my rules for negative reciprocals. Negative reciprocals have opposite signs. And when I talk about reciprocal, that means my numerator and denominator have flipped. So to find the reciprocal, switch the numerator and the denominator. So they have to be opposite signs. So what I'm going to do is I'm going to come over here out to the side and write negative reciprocals. Whoop. Must have one opposite signs to fractions that are flipped. Numerator becomes denominator, and denominator becomes numerator. Okay, so that's what they mean by flipped. They have to have opposite signs and be flipped. So in that particular example, we had one slope, and come back over here to where we've got the intersection. We had one slope that was 2 and one slope that was -1/2. Okay, so one of our lines had a slope of 2, one had a slope of -1/2. So my two rules for perpendiculars, my two rules for negative reciprocals is one is positive, one is negative. So we look at that. Is one positive and one negative? That's the first question to ask. And yes, my first one is positive. My second one is negative. Remember that 2 is the same as 2/1 when written as a fraction. My second thing to ask myself is, are the fractions flipped? And the answer to that is yes, because one is 2/1, the other is 1/2. So for negative reciprocals, one is positive, one is negative, and the fractions are flipped. Okay, those are my two rules for negative reciprocals. Remember, negative reciprocals, perpendicular lines. Perpendicular lines intersect at a 90-degree angle, which is also called a right angle. So let's go ahead and take a look at classwork 1. And we've got the number -4. First of all, I need to write that as a fraction. Okay, so -4, I could write as -4/1. Now, what is the negative reciprocal of that going to be? Well, if it starts out as a negative, what is my negative reciprocal going to be? It's going to be positive, right? If it's 4/1 to begin with, to flip it will be 1/4. So -4/1, the reciprocal is +1/4. Let's look at 1/7, what we begin with. I start out, it is positive, so the negative reciprocal has to be negative. Then when I flip it, it's going to be -7/1, which is the same as just a whole number -7. Okay, so 1/7 is the negative reciprocal of -7. Now let's look at -6/11. It is negative, so my negative reciprocal will be positive, and I have to flip my fraction. So two rules. One is positive, one is negative. One has the numerator and denominator, the other one is flipped so my denominator has become my numerator and my numerator is my denominator. Okay? So now they've given us, and it says identify whether or not the two lines are perpendicular and tell why or why not. So let's look at this first one. What is my slope of 4x plus 7? My slope is 4, right? Now I'm going to look at the next one, -4x plus 3. My slope is -4. Let's look at our two rules. One, let's see, is one positive and one negative? Yes, one is positive, one is negative. But then my second question, Are the fractions flipped? Or if this was 4 over 1, this is negative 4 over 1, are my fractions flipped in these? No. So therefore, they are not negative reciprocals because fractions aren't flipped. Okay? Does everybody see how we did that? We looked at the slope of the first one. We looked at the slope of the second one. And then we had our 2 tests that they had to pass. Number 1, are they opposite signs? Yes. Number 2, were they flipped fractions? No. If my answer is not yes to both of them, then they are not negative reciprocals. So let's look at the next one. Y equals 2/3 x minus 5. So what is my slope on this one? It's going to be 2/3. Look at the next one. Y equals 3/2 x plus 2. My slope is 3 over 2. So my first question is one positive and other negative? Nope. So I know immediately that these are not negative reciprocals. Now, step 2, are they flipped? Yes. But that's not enough. I can't have a yes and a no answer. So they are not because one not negative and other positive. Now they've thrown us a little curveball here. And they have given us 3/5 x plus y minus 1 equals 0 and 5/3 x minus y minus 3 equals 0. I cannot pick my slope out of either of these equations. Why? Anybody have any idea why I cannot just look at this and say that m is 3/5 and m is 5/3?
It's not in y equals mx plus b format.
Perfect. They are not in y equals mx plus b format. So that's the first thing I've got to do. I have got to change them to y equals mx plus b format. If they are not in that form, then I cannot identify my slope. Okay, so let's look at the first one. I've got 3/5 x plus y minus 1 equals 0. I've got to isolate y. So that means I need to subtract 3/5 x and add 1. If I do it on the left-hand side, I have to do it on the right-hand side. Subtract 3/5 x plus 1. So y equals negative 3/5 x plus 1. That's for my first one. My second one was 5/3 x minus y minus 3 equals 0. Same thing here. I've got to put it in y equals mx plus b form. So I've got to subtract 5/3 x, subtract 3, subtract 5/3 x, and subtract 3. So now I have negative y is equal to negative 5/3 x minus 3. Can I leave this like this? If I'm solving for y, can I have it as a negative y? I cannot. Y has to be positive. So I've got to look at this and say, okay, well, if y has to be positive, what could I multiply or divide by that would keep my values the same? What number have we learned using our properties that I can multiply by and it will not change the value? Chad?
Isn't that 3 supposed to be positive?
Yes, thank you. okay? So if we look at this, what would I have to multiply everything by to change negative y to positive y? How could I change a 5 from a negative 5 to a positive 5? What would I multiply by?
The reciprocal.
Not the reciprocal, but I can multiply by -1. Okay, remember, if I multiply anything by 1, it's that number. But if I were to multiply it by a negative, then, so what I'm going to do here, I need to multiply by -1. So -1 times a negative y is now a positive y. -1 times negative 5/3 x gives me a positive 5/3 x. -1 times +3 gives me a -3. So if I have negative y, I must change it to a positive y. The way that I do that is to multiply my entire equation by -1, because that will change the signs. But you can notice that all it did was negative y became positive y, negative 5/3 x became positive 5/3 x, and +3 became -3. So all I'm doing is flipping my signs of every single term in that equation. Okay, so now let's take a look at what we've ended up with. In my first one, m is equal to -3/5. In my second one, m is equal to 5/3. Okay, so these are the two things we're looking at. Is one positive and one negative? Yeah, the first one is -3/5. The second one is positive 5/3. So there's our first yes. Second, are they flipped? Are they reciprocals? Yes, one is 3/5, the other is 5/3. So these are negative reciprocals. Opposite signs, fractions flipped. Okay, so that is my rule for perpendicular lines. They have to have slopes that are negative reciprocals. So let's go ahead and take a look at activities 2. What would my negative reciprocal of 12/5 be? What would my negative reciprocal of 12/5 be? It's already positive, so that means I know my negative reciprocal has to be negative. I've got 12/5, so I have to flip it to -5/12. So the negative reciprocal of 12/5 is -5/12. Look at 1/3. What is the negative reciprocal of 1/3? It is positive, so I know my negative reciprocal has to be negative. I have 1/3, so I know I have to flip it and make it 3/1. And I can always simplify that just by writing it as a whole number if my denominator is 1, so it will be -3. And then the last one, -2/5. My first one is negative, so my negative reciprocal will be positive. And then I just flip it, 5/2. Any questions about negative reciprocals? Remember, there are 2 tests that they must pass. One is positive, one is negative, and that the fractions are flipped. Those are my 2 tests for negative reciprocals. All right, so right now it is 11:53. The first thing we're going to do right now at this time is we're going to do like we did a minute ago. Notice that my first, let's see, let's go ahead and number these in activities 3. Let's go down. 1, 2, 3, 4, 5, 6. Notice that 1, 2, 4, and 6 are already in y equals mx plus b form. So all we've got to do is look at my m values. So if m equals 7/10 on this one and m equals -10/7. First question, are they opposites? Is one positive, one negative? Yes. Second question, are they flipped? Yes. So it says identify whether or not they are perpendicular, tell why or why not. And put yes, because one positive, other negative, and fractions are flipped. Okay, so let that be your guide. Now look at number 3. Let's look at number 3 together. My first step is I have to solve and put it in y equals mx plus b form. So I've got to do that first. So I have 5/8x plus y equals plus y minus 3 equals 0. That means I have to subtract 5/8x from this side and add 3. Subtract 5/8x and add 3. So y equals -5/8x plus 3. So then, if you want to, you can circle or put a box around m so you can focus on that. That's what we're going to be comparing. The next one, I have -8/5 x minus y minus 2 equals 0. So I need to add 8/5x, add 2, add 8/5x, and add 2. So negative y equals 8/5 x plus 2. Again, I cannot have a negative y, so I need to multiply everything by -1. So now I'm going to have y equals -8/5 x minus 2. I'm going to put a box around that -8/5. So now I'm going to focus on, I have m equals -5/8 and m equals -8/5. So I'm trying to determine, are these negative reciprocals? So I have -5/8 and -8/5. Do I have one positive and one negative? No, they're both negative. So they are not negative reciprocals because one isn't positive and other negative. They are reciprocals, they are flipped, but one's not positive and the other negative. So with our last few minutes, I want you to do numbers 2, 4, 5, and 6. Notice number 5, you're going to need to put into y equals mx plus b form. For 2, 4, and 6, all you have to do is look at what is the value for m. So take a few minutes to work on that. Let me know if you have questions. Okay, so take a look at these. Number one, we did together and said yes, because they were both opposites and they were reciprocals. They were flipped. Number two, I have a slope of 2 or 2 over 1, and I have a slope of -2 or -2 over 1. They are not, because the fractions aren't flipped. They are not reciprocals. One is positive, one's negative, but they are not reciprocals. Number three, we did together and found we had -5/8 and -8/5. They were not reciprocals because one wasn't positive and the other negative. They were flipped, so they were reciprocals, but they were not negative reciprocals because they did not have opposite signs. Number four, I have 8 or 8 over 1 and -8 or -8 over 1. I do have opposite signs, but I do not have reciprocals. Number five, you had to change it to y equals mx plus b form. So you should have ended up with y equals -2/9 x plus y, and y equals 9/2 x minus 4. On that, we ended up with a -y. So again, I had to multiply everything by a -1. So that made my -y become positive, -9/2 became positive, and +4 became negative. When I look at my two slopes, I have a -2/9 and 9/2. They are opposite signs, and they've been flipped. So they are negative reciprocals. And finally, number 6, I have 3/7 and 7/3. They have been flipped, but one is not positive and the other negative, so they are not negative reciprocals. Any questions on those? All righty, so what I'm going to do is on Thursday, we will pick back up and we're going to talk about graphing negative reciprocal lines. So we will not do any book work for homework. Okay, what I will do is I will send you the packet this evening. It'll be by 5 o'clock, if not before. So by 5 o'clock, you will have your packet in your email. Okay. And I will give your assignment on that. Okay. I will also on your packet, I'm going to identify which lesson the assignment corresponds with, because y'all know we've had lesson 29, 30, 31, 32, 33, 34, and this is 36, right? 35, 36. So we've had numerous lessons that your packet is going to cover. It's going to be reviewing some of the previous lessons. Okay. So by 5 o'clock, if not before, your assignment will be in the email. And if you have questions, let me know. If not, then I will see you guys on Thursday. All right. All right. Bye, guys. Have a good week. Thank you.
Bye, Jennifer.
Bye. You good, Sadie? Sadie, are you there? You okay, Sadie? Oh, there we go.